I think we can get started. So welcome to the infrastructure group conversation. Questions, we're taking questions. Okay, should I just walk through the slides and see if, as I talk about these things, questions come up? Share my screen. Okay, I hope you can all see that, if I did this right. Because I've been known not to do this right. So I split this group conversation in two. I'll talk a little bit about reliability and some of the foundational aspects we're focusing on, because those, I believe, need to get a little bit more attention and wider attention from the company, because they're important, but because they're foundational, they're kind of hidden. And then Marian will talk about delivery, because they're doing a lot of very significant work that I think is exciting and moving how we're doing continuous delivery and continuous integration. So first, welcome to new hires. We have 2 new SREs and 1 DBRE. We're coming from all over the globe, and then we just recently heard that we actually have another hire on the way from the UK. So welcome, everybody. We're very excited to have you here. I wanted to take a little bit of time to talk about the storage nodes, which today are running the exe4 file system, which is actually a great file system, but I think we can do better. And in discussions with the team, we've decided to move to CFS, which is essentially a volume manager and file system in a single tool, and it has some advanced capabilities that we really like. It has a long history, is well tested, is supported in multiple platforms. A number of people on the team have had long experience with this file system, and we want to address sort of taking a page from the security team about security in depth. We want to implement data protection in depth, so we want to add as many protection layers to the data that we host as we can. And there are 4 aspects that we're worried about: file system corruption, unwanted deletions, meaning things we didn't mean to delete that we quickly need to recover. Disaster recovery itself. Geo has been working well for us, and the Geo team has been amazing in addressing issues that we've run into. But there are some things that we can actually add, again, additional layers of protection by using CFS. And then testing, which is something that we've been trying to implement more extensively for a while, but it's expensive because you end up having to replicate data. And what we want to do is to do so in a smart way. So CFS gives us a very simple tool that implements a volume manager and a file system. It's a very advanced file system, has a lot of data protection built in. It's always consistent on this, so you never need to FSCK CFS. It provides snapshots.
I'm really sorry, but this is terrible. Like, what is going on here? Like, this is like, I run database systems that are 10 times the size of GitLab, and we didn't need ZFS. Like, this is ridiculous.
Why?
Like, these kind of data protections should happen at the database layer, not at the file system layer. Like, this is solutions looking for a problem, and I really don't understand this.
And well, I have FSCK'd exe4 file systems where for some reason the file system has corrupted itself. So yes, in the storage nodes,
you don't. When do we FSCK a database server? You shouldn't. You should fail over to a clean database server. Like literally, In the years and years and years that I've been running database servers, I never did anything to the online FSCK database. Like it was always done offline in triage after we failed over to a replica. Like there's no way that we should ever be worrying about FSCK on a database. Like that's
hang on just a minute. Why are you assuming this is database only? Actually, the data in the database I know is very well protected to Postgres replication, but the data on the Git nodes is not. Today we do snapshots at the file.
And we're already solving that at the Git layer, is we're building HA Git, and we will never need the FSCK Git server because we can simply replicate to it and fail over. Like these are things that should be handled by the software database and data storage layer, not by the file system.
And there's nothing preventing you from doing that.
Yes. And so why are we wasting time on this? Like
because, for instance, we've gone through data that has been deleted that has taken us hours to recover because we didn't have local snapshots. That's a second operation on something that has local snapshots. We also want to replicate terabytes and terabytes of data in a smart way. I don't want to run 3 environments that are running at 3 times the size of the production environment. I want to use clones, and then once I do a clone, I expose that clone. People can use actual data at the scale of GitLab.com, and when they're done using it, I've used a very tiny delta from the production data set. These are things that I cannot do on ext4. These are things that the application cannot do. Pardon me?
I'm gonna interrupt here a bit, Ben. This is, I think there's something in what you say that makes a really good point, but I think we should be kind of kinder to each other when presenting the point. And I think we should definitely talk about this, but like saying this is terrible without any qualifiers is a way to get in a very heated debate. And we need this passionate debate.
I agree. I apologize.
No worries. I know we can be passionate about these things. I suppose I also come from environments where CFS has actually done wonderful things for us. And we wrote the blueprints, we wrote the design, they've been available for a long time. Happy to sit down about it, to sit down and talk about it in detail. Again, I'm not saying that this solves everything and that this is the only solution. I'm saying that we can build multiple layers that can help us better protect the data. So there is no reason why we shouldn't continue doing some of the other things.
Anyway. And just to maybe clarify a bit, this is not like a substitute for database failover. This is not a substitute for backups. This is not a substitute for at some point having Git HA with multiple Git servers. It's not a replacement for any of these. This is like a backup or data resilience in depth, where this is another option available on our toolkit.
Right. I mean, it's just an additive thing. So yes, that is totally correct. And this is why I said I was taking a page from security, because they do the same thing. They build these layers to protect, and as safety belts fail, you still have some more reliability.
And if we have a problem on the database disk server, the first action will probably be to fail over and figure it out. Right. Figure out what's wrong on the disk later. Like, I think we agree with Ben's point there.
Yeah, totally. I mean, we're not stopping doing these other very important things in favor of CFS. So,
well,
anyway,
my point is opportunity cost. Is this work is blocking other work?
Is it blocking other work? What work is it blocking?
Actually, let me look at the slides and see how many slides mention Kubernetes migration.
Kubernetes is being worked on. This is not a man-month problem. Me adding more SREs to Kubernetes isn't going to get to Kubernetes faster.
Well, how many of the SREs are working on this right now?
There's at least 2 of them. Scarbeck has been working on this.
How long do we think this effort will take?
This is available for this quarter. No, we still have to do the migration and all that. But again, there is a number of things that, I mean, Kubernetes is an important thing, and no one's denying that. But if I speak to people who want to do testing against production data sets, I cannot offer that solution at an even remotely reasonable cost today or performance, because I need to continue copying this data over and over again. So this isn't solving all the problems perfectly. It's solving some problems that I can't solve any other way. And it's not, yes, it's taking some resources because we're making some investments on things like testing environments. And the number one thing that folks have asked over time about being able to test is, I need to test with production scale data. And Geo doesn't do that. Geo gives me a copy, but I can't touch that copy. And if I want to copy that copy, then now I have 3 copies. With CFS, I only need 2 and whatever little deltas, and I can create a gazillion clones for people to test against their apps on ephemeral environments. My dream is for an engineer to say, I've built this new feature and I want to test, then off I go. And here is my big data set. And it's super cheap to do. Again, I think I am more than happy to have a deeper conversation as to why we went down this path and why we decided to invest some resources on this. There is no argument about it. So I'll set up a coffee with you, Ben. All right, let me move on to the next one. So another very foundational thing we've been working on, Amar has been working on this and other members of the team, is our services information is very imprecise. There's a lot of tribal knowledge of where things are and how they work. And so we've invested time in essentially standardizing how we represent services in terms of metadata. We use this for automation. We use this for monitoring. We use this for figuring out incidents and dependencies and some other metadata that we need to essentially carry out our business. So we've developed a service inventory that has an API in front of it, and it offers structured data about services. This will allow us to not just do better automation, but also to perform auditing. So when services have to meet certain characteristics, that means that we can ask the service for information and decide whether a service is actually in an operational state that we can work with, versus runbooks and handbooks and wiki pages, not wiki pages because we don't use that. But so this is up and running. Amar wrote the service catalog, I believe it's called. Andrew helped with that. They put a UI in front of it, which is super nice because now we can go and ask questions and get very structured answers.
Jerry, this is Anthony from the security team. Yeah. I had added a question to the doc on this. And can you just give some examples of what services are the kinds of things that are in this? Are we talking about external dependencies like Mailgun, internal services?
This is all internal. Okay. At this point, this is all internal. So this is essentially our internal topology. And we want to be able to do things like we have a service inventory and we keep the owner as part of the metadata. So when we're calculating error budgets, we can say, oh, this incident affected this service. This is the team that it belongs to. I haven't looked at the entire spec, but there is a significant chunk of structured data that you can get about services. Eventually, I think monitoring specs can go in there. So we're starting to essentially plop down in a single place what our environment looks like and doing it in a way that our tools can ask questions when we need them. So today, for instance, some services that are very obvious, like Gitaly, but other services are not as obvious. So this is our first iteration to say, here's the phone book for the services we have today. And that doesn't necessarily map to specific components because the application provides many services. So this is a way to do away with tribal knowledge and have this in a way that is consumable by tools. If we eventually find that we need to extend that to external services, the model is simple. It's just a bunch of attributes. So if we needed to do that, I think it's just adding the data, and there may be some other attributes that we may need. That would be fine as well. I mean, again, this started as a YAML file that Andrew created, and then Amar expanded that and cleaned up the definition, and then built a thin layer that allows us to ask questions about services. And then they actually want to build this really nifty API UI. I mean, it's simple, but now I can go and find out things. So when I'm cranking through error budgets, this is a lifesaver.
Great, thanks.
Cool. Let me see. Sorry, I never did this right with screen sharing, but let me see if there are more questions.
So I had a question in the doc. I can repeat that if that's okay.
Yes, I'm looking at the door. Service information. Yes. Are we considering tracing? I know Andrew instrumented to get that. Yes. I don't know how Andrew or if Andrew is actually wiring these two together, but I know that if experience has shown me anything, it's that once we have this more authoritative catalog of services, more things will consume this data. So if I assume Andrew's on the call, he may be able to answer way more authoritatively than I can. Or he may not be.
It's all good. You can follow up offline.
But minimally, I would imagine the naming of the services, because in some of the tools we've written in the past, a single uppercase, lowercase type thing essentially makes the tool say, oh, this is not the same as this. So that should take care of that.
Sorry, I don't think I understood properly. So basically what you're saying is the way you guys have set up the self-service data source with the metadata is how you're going to like join things together to make a trace. Is that what you're saying? Which is different from...
I don't know that the tracing system would use a service directly, but I would imagine that it does use, for instance, how we represent a service name, so that we have a single representation of a service name. So that when you capitalize or maybe it's by ID and then you can look it up. Mm-hmm. I know that we're looking at using this with other budgets, for instance. So instead of me saying this is Gitaly and capitalizing the G or not, we just say that is the thing that had an issue, and what that is named, I find out later. And if we ever change some name, or in the case where, for instance, we decide to break up services for some reason, by using the centralized service directory, we can do those things, and the tools will consume the data. We're not hard-coding service data everywhere.
And so when you say they will the service data will tell us what the name is, is that a visualization or is like yours?
There is a UI that the team built for it. Essentially, that was the first thing they built, so that we could actually play and interact with it. And then they built an API so that we can consume the JSON that the API calls return. So if I'm writing a tool that requires the name of a service, so error budgets, for instance, then those are API calls against the service to get the information it needs. Because maybe, okay, I know from an incident, it was caused by the service, and then I need to do attribution to the team. So instead of hard coding that in a spreadsheet or everywhere, we just know that that team owns that service. The great thing about that too is that, let's say that a service moves teams, right? So some other team takes over a specific, then you just update the directory, right? And so when I ask that same question 3 months later, I get the right answer.
Yeah, and do we go deeper than the service layer level? Like, do we go to functions and like, okay, within this service, here was the problem?
I'm not sure I follow.
So if you have a service, it's like various components within the service, right? Like there was a call made, then there was a response that came, and then this happened or whatever.
So like, this is less concerned with tracing in terms of following. Think of it more of if the trace says I hit service X and then service Y, if I need more metadata about service X and then service Y, then I get it from the service directory. So this is very contextual, right? So if I need to set up let's say that I do some dependency monitoring, and I say service A depends on service B. And so if service B is having an issue, don't page me about service A. Just let me know that service B is broken. So we can build some of this functionality with the directory. Right now, the directory is just very simple. We really want it mostly to capture, sort of do the breakdown of the services to begin with. Who are the owners? And then there are a bunch of other attributes that the team decided we needed to service automation. but this, I mean, we'll continue to iterate on this.
Cool. Thank you.
Oh, thank you. Let me see more questions. Robert, how are we mitigating the risk of CFS not having direct kernel Linux support? Has that changed in the last year or so? I believe it has, because I believe now Ubuntu actually ships it as part of the kernel. I know we had some conversations about the legal aspects of this, and we decided that, yes, we could do it. I don't know the details. I believe they're in the blueprint. If not, I can definitely get the details. Ben, what is our Kubernetes plan? What is the timeline? What is the holdup? Kubernetes is being worked on, and we're shipping 2 services, I think this quarter on Kubernetes. So it is in progress. It's one of our KRs. So it's being worked. But if we want more details about it, Dave would be the person to talk to. Because right now I don't have all the details, but we're working on it this quarter.
Can you, actually following up on that, I'd love to understand what the move to Kubernetes will do for us, and just in a snapshot, if you can share, what will change after we move to Kubernetes?
Oof, now I'm a little bit outside my area of expertise.
I can give a nice example of how it would help things. For example, I spent the better part of 2 weeks simply trying to scale up the number of web workers because the process required a significant amount of overhead to just simply, I'd like to have some more web workers and some more web nodes, and getting that spun up and getting that available was not something I could do easily with the current infrastructure. And on Kubernetes, it would be a significantly simpler change to say, make me some more pods, and they would appear.
Right. Okay. That's super helpful. So that's something we're running into daily already.
Correct. The current infrastructure takes quite a long time to reconfigure.
Thank you.
So Ben, have we moved our Prometheus servers?
No, not yet. We've been working on getting the data storage transferred out of the local disk and into Thanos storage. I just completed one of the downstepping of the production data storage so that the Prometheus servers only need to store now a week of state in order to operate. And we'll actually be stepping that down to 24 hours of state locally within each Prometheus server, and that will allow us to migrate those to Kubernetes pretty easily.
Cool.
Okay. Maren, delivery.
Yes, I can give some color on the slides, but I'll start with just repeating that we have 2 backend engineers assigned to infrastructure, Alessio and Myra, starting next week. And we are already starting to work on introducing some feature inside of GitLab that have been a lower priority, but have a higher impact on GitLab.com, such as storage limits that obviously is impacting our costs as well. And I'll just quickly run through the single code base effort, where we're making quite a bit of progress there. I think the graph of the diff between CE and E is trending down. And we are somewhere in the area of, in the year of 2015, we had the diff between CE and EE the same as it is now. So there is a lot of great work being done by the whole engineering, because this is an engineering-wide effort. And soon we'll know a bit better whether we are going to reach that ambitious deadline of May. We are removing some manual steps from The security releases scaled up significantly in the past 2 months, 3 months actually. No, it's April, 4 months. So a lot of manual work created serious amount of overhead, and we automated a number of previously manual tasks like picking, like ensuring that things are backported correctly. And I think that is already having effect on how we can ship faster. And going further, we introduced new environments where we are going to be testing our new, I'm just checking time, where we are going to be testing some of our new tooling, and we are on our way with automated weekly deploys. So whether that's done with Kubernetes or with whatever, it doesn't really matter at this point. It will very much matter as we start speeding up this deployment process. So we need to change some processes around development as well as how things end up in production. And finally, just a plug there, you can check out some of the training sessions that the team made and some of the conversations we had, all of it on YouTube. So we are at G_delivery in Slack. If you have any follow-up questions, I'll be more than happy to answer them. I think we're also at time, Jerry.
I will have 4 more minutes. I'll take more questions if we have.
We try to end 8:25.
Oh, okay.
We do short meetings
I'm
here.
sorry.
No time to have bio breaks, straighten out their hair, or do other things.
All right. I'll go deal with my hair then. Thank you. Bye, everyone.